Thank you so much. I hope you can hear me. I'm going to skip a couple of slides, but basically, here's a quick introduction for my background. Easiest way to think of me is a recovering geek, if you will, but you can't take a geek out of a person after all. And the team is basically a team of very interesting math and science experts out of Stanford, MIT, and to some extent Harvard, multiple math Olympiad gold medals, etc. And we have gotten several awards. Let's skip through all this and get to the meat of the real presentation. We believe access to analytics is broken because what is important is how do we get everyone who impacts the business outcome for whatever we are trying to do, how do we get analytics to them? And the issue becomes that today senior executives and to some extent middle management have access to analytics, but the majority of the organization actually doesn't. And from our perspective, it is actually more important to have the admitting nurse have access to analytics than it is perhaps to have the CIO of the organization have direct access to analytics, because that admitting nurse can have a bigger impact in some cases. The second issue is everybody is talking about big data and advanced analytics, and what they forget is big data does not equal manual analysis, right? So for example, people are trying to do a lot of effort around looking at what more data can I add into my analysis? But as they start looking at different variables, for example, one of the hospitals we're working with, they wanted to analyze things down to the level of what hospital bed was a patient in and what X-ray machine took the X-ray of the patient, because their concern was, could we track down an infection, for example, to a specific bed in the hospital? And if there's a lot of infections happening in that bed, maybe we find out that there is a vent somewhere near there which is causing the increase in risk of hospital-acquired infections, right? So you're getting into a lot of variables. The problem is the moment we start looking at more and more variables, and we want to look at second, third, fourth order variables, combinations such as if you're looking at a medication, forget about personalized medication, at the very least you would want to know what medication is better for me given my gender, given my race, given my smoking history, perhaps my BMI, right? Even at that point, you're at a four-variable, fourth-order analysis, right? And the amount of computational complexity goes up exponentially. So if you're looking at 100 variables and you want to look at fourth order, you would have to write 94 million calculations. That's clearly not possible for a human analyst to go look at all of that. And of course, you must have read this McKinsey report that talks about the unmet demand just in the U.S. for 140,000 to 190,000 analytical talent. But what we find even more fascinating is the need for a really large number of business users to become trained in statistics. Fundamentally, I don't think this is a problem we can solve with training or through outsourcing. Some people are trying to outsource this. In fact, what I found really funny was this year we got the Gartner Cool Vendor in Business Process Services, and another company that got the exact same award is Mu Sigma, whose premise seems to be, well, I have analysts for $40 in India. So I don't think that model is long-term going to scale because there's just too much data. You're not going to outsource your way out of the problem. So what we believe is there's a need for a new approach to analytics, which we call advanced analytics for all. And I'm going to go through the principles of advanced analytics for all, what we're trying to do, and what we are encouraging other organizations to do, and then go into a case study. By the way, on a separate hat that I wear, I chair the Big Data and Advanced Analytics Special Interest Group at the Service Research and Innovation Institute, which was started by IBM, HP, several others. And that's one of the efforts we are doing in that group is how do we help analytics companies understand how to truly impact outcomes, which is going to be through simplicity and making the technology more pervasive, more easy to use. It's not just going to come from computational complexity, if you will. So one of the things that we started out when we first looked at the Advanced Analytics for All premise, I basically went to my engineers and I said, you know what, SAS code is, and this is an example of SAS code, it's just too difficult to do. We can't require people to have any statistics or computer science knowledge to have to do analysis. And they fought with me a little bit, but then they got the point and they went in and built a product. The problem was the few people who can actually do something like that, where they can enable an analytics platform which does not require computer science and statistics skills. Well, they are such experts in statistics that every aspect of statistics is easy for them. Right? So it almost became a self-defeating goal from my side to tell the best statistics experts, make the product not require statistics skills. So then we went in and said, well, you know what? It can't require a keyboard. Everything a business user has to do to run an analysis has to involve nothing but selecting. Because that's something a business user can do. And if we can get a solution where a business user just comes in and says, hey, here is my business outcome. So in the case of the example I'm going to show you, the business user comes and says, I want to look at excess length of stay. So how long did the patient stay in the hospital, less the amount the Center for Medicare and Medicaid suggests is the appropriate length of stay for that diagnosis, right? I want to look at excess length of stay. I'm not going to tell you anything else. Go look at every other variable combination, figure out how that affects my length of stay. That's something a business user can do because all they're doing is going in and selecting something. Another interesting benefit of this approach is organizations are very concerned about the quality of the analytical code that's sometimes written and the maintainability of that. So, for example, Deloitte's Economic Consulting Group used to have 2 PhDs create the same SAS code because they were afraid that one PhD might make a mistake, so they would use up 2 PhDs to run the code just to make sure there were no mistakes in it, right? Whereas if you have a solution which is focused on visual approaches, it's very easy for another analyst to come in and look at an analysis setup and say, oh, I see what variables have been selected, I see what options have been selected, okay, I get this, right? So it becomes organizational knowledge, not individual knowledge. But that's on the analyst side. The other side is the consumer, the person who's going to look at the report. The problem is human beings do not communicate in terms of mathematics. Think back to all the conversations you have had with your friends, even analysts. Think back to the conversations you have had with your business users. The conversations always came around to stories. Stories and examples is exactly how human beings tend to communicate with each other. So let's say I come in and tell you the diagnosis code, the name of the hospital, and maybe physician is highly correlated to excess length of stay. And I tell you that the R-square is 75% for these 3 variables as opposed to R-square being 55% for another set of 3 variables. The reality is some experts may get what we're talking about, but to the vast majority of people in the organization, I just spoke Greek, right? It doesn't mean anything to them. But if you go to that exact same people and you say, look, we looked at a procedure. In this case, the example on the right-hand side is a procedure called tracheostomy, where you cut a hole in the throat. And the software found that this hospital in Detroit is taking 14 days longer, is keeping patients 14 days longer than this other hospital in Chicago. Now, that is actionable. Because firstly, you immediately understand how important this is. 14 days difference in length of stay is a huge difference. At the same time, tracheostomy is something that is a very specialized treatment. It can be that a person had an infection and thus they had to do a tracheostomy and there are complications involved in it. So it may or may not mean that there is a fundamental problem. But now I know where to look. If I think of all the diagnosis codes I could have looked at, all the treatments I could have looked at, now I know, okay, of all the things I could have looked at, let me go take a look at tracheostomy. Also, when people are talking to each other, when they collaborate, it's much easier for them to say, hey, I want to see what's happening with Chicago for tracheostomy than to say, I want to look at how the variable hospital is getting affected by the treatment code, for example. Next is collaboration. Now, in the first of the advanced analytics slides, I was talking about how you want to have computers run the analysis. And that, of course, runs hypothesis free. You're basically not going in and saying, hey, I'm going to go look to see how diagnosis affects outcome. You're just going in and saying, show me what's interesting. But human intuition can never be taken away. So the example of the tracheostomy one I was talking about, it might very well be the case that when you pull the files, you find this is not a problem at all. Detroit actually had a case mix that makes it perfectly valid for that to have happened. So you need human intuition, but how do you do that? You can't do that through in-person meetings. So if you want advanced analytics for all, what you need to do is social collaboration. So people need to be able to come in and look at a graph and comment on it and see and ask a question to their colleagues. And if I've asked a question to my colleague and my colleague comes to that same site and clicks on my question, they should be able to see exactly what graph under what settings was I looking at when I asked that question. Is there a part of the graph that I was interested in? And that's how we need to overlay human intuition on top of the automated analysis. So you don't throw away human intuition, but instead of putting it at the beginning of the analysis where you force humans to find hypotheses and they may not think of the right hypotheses, you're putting the human intuition in the back of the analysis where interesting statistically sound patterns have been found, and now the humans come in and say, why is this happening? What is happening? Add that richness of human intuition on top of that. The next thing, and this is crucial from my perspective, a lot of analysis companies are basically taking the position of, hey, I encrypted the data, I provided you a password, now I'm done. I'm going to put a legal disclaimer, and that's the end of my thinking around privacy. Now, this is a fairly dangerous approach because it's almost like giving someone a loaded gun and saying, I didn't even put a safety into that gun, but if you shoot yourself, it's your own fault, right? And this is going to become one of the big problems with big data analytics because people are already getting a little nervous about this Orwellian world that would come about if we have this kind of lack of consideration for privacy. Now, one information that will probably scare you a little bit is Harvard, this lady who heads up Harvard's data privacy lab did a research where she showed 87% of the people in the United States can be uniquely identified by just zip code, date of birth, and gender. Just zip code, date of birth, and gender. You don't need anything else. Now, that's a very scary thought because most of us don't think of that as private information, but this becomes a problem because people today are doing search-based attacks. And if most zip codes have so few people that you can run a search-based attack and identify the individual. So Harvard came up with this idea called K-anonymity, where the idea is when I run an analysis, I should never be able to get more specific than 35 people. So if I wanted to figure out whether a certain individual had a disease, I might, in a normal system, I might be able to go in and type in his age. Even after he's been anonymized and masked, I might be able to go in and type in his age. I know kind of what hospital he would have gone to because it's the closest hospital to his house, and I put in, maybe I have racial information nowadays. I put in some information and I get specific. But K-anonymity says the moment you get more specific than 35, you don't get to see any further. The interesting thing about it is for statistical analysis, you actually don't care about a cluster whose size is less than 35 that much. So you are getting all the insights, all the statistical insights you could have wanted, but you're not revealing any of the privacy, any of the secrets. And again, we believe that as organizations start thinking about advanced analytics for all, if they don't bake privacy and security into the offering and make it a afterthought or make it something that you do through legal disclaimers, it's just never going to work. The next thing is how do you do the infrastructure? And I'm going to be very, very quick about this. The way we do it, but there are lots of approaches. We made the analysis server in Java, and we made the reports in pure HTML5. Now, why pure HTML5? Because that way you can have the report on an iPad, you can have it on an iPhone, you can have it on an Android device, you can have it on the cloud, you can have it on your web server, you can have it on your laptop, and it doesn't matter. It's the same code running everywhere, which really brings down the maintenance and organizational costs with these kind of technologies. Because if it's not simple to use, it's not going to be pervasively deployed, right? Those are the primary approaches towards advanced analytics for all. But let me show you a specific example and how we leverage these. So this is one of the leading hospital systems in the US, and they wanted to have us take a look at the patient length of stay patterns to figure out ways to improve the patient experience. And what we had to look at was 247,000 patient outcomes in this case. But if you look at the number of variables they had, to just look at third-order analysis, we actually had to evaluate 534,000 variable combinations to figure out what variable combinations were important. And we had to do about 9 million calculations to figure out what variable combinations were important, because you want to do several statistical tests. You want to make sure the pattern you're showing is really statistically sound, to the point made by the gentleman from Microsoft up front. If you just do a naive analysis and you don't do the statistical tests, you can be looking at a lot of confounding factors. You want to make sure that the the pattern you're presenting is real. So we had to do about 9 million calculations. But after doing all of that, what the software did is it came out and said there are 35 key insights you need to look at. So it went from raw data to 35 key insights, and let me show you 3 of them, and I'm going to give you a quick slide on each of them after that. So the first one was the tracheostomy example I talked about, where people were 14.5 days longer in one hospital compared to the other. The second was kind of interesting, where we found that when a patient's diagnosis was altered mental state, people were staying 7.5 days longer in the surgical ward. And we went in and talked to the executives, and they figured it out actually fairly quickly. Because what happens is, if the patient has altered mental state, the surgeon is often worried whether they'll get the follow-through treatment, right? And so what they're doing is they're keeping the patient in the surgical ward just to make sure that they're getting the right follow-through. But if this had been planned for, the moment you have a patient maybe with a psychiatric problem, if you had arranged to have the patient released to a psychiatric ward under appropriate care, you could have freed up the much more expensive surgical bed, which hospitals are always in short supply for, right? So that's an example of a pattern that once exposed to the client, people can quickly collaborate around it, and they kind of intuitively knew this was happening. They just didn't know the extent of the problem. So the extent of the problem becomes very clear, which allows people to rally around and act on it much more easily. The next one was a situation where, and remember, it controls for all possible variables, and one of the variables was the actual insurer. And what we found was, for a certain treatment, people who had one insurance were staying 20 days longer than expected. Now, this is a pattern that is very, very intriguing, because on one hand, it might very well be that this insurance is an insurance that only people with really significantly bad diseases take, and so there is nothing surprising about the fact that people are staying longer. Or it might be it's a very high-end insurance that allows people to stay much longer. Or it could be a situation where an insurer is getting perhaps a little bit overbilled because they're paying by how many days a patient is staying in the hospital rather than based on the diagnosis, right? So if it's the latter, then hospital actually needs to figure it out and fix it before they get into potential embarrassing problems. Whereas if it's the earlier, it's just a false positive. It doesn't matter. But what happens today is if these patterns exist, if people staying longer exist, these patterns are going to be specific to specific hospitals for specific treatments. It's not going to be every hospital, every treatment that has that kind of overbilling situation. And administrators don't have the time to go look at every single diagnosis. So if they can quickly figure out where there are potential problems, they can quickly collaborate around it and figure out, is this a real problem? In that case, let's get ahead of the problem and let's fix it. And people tell me I'm naive, but I fundamentally believe that every one of these executives want to do the right thing. It's just that most of the time, they don't have the information at their fingertips to act on it. And most of the time, they can't quantify the extent of the problem, and they can't collaborate with their organization to figure out how to act on it. By simplifying what they look at and how to communicate with the rest of their organization, you can actually enable this kind of proactive collaboration. This is the example of the tracheostomy one I was talking about. If you saw this graph, by the way, those two call-outs are things I added, but otherwise that's exactly the screenshot you would see on your computer. And a human being can look at that and very quickly figure out, oh my God, I have a length of stay pattern that is intriguing. The next one I'm showing you is one of the insurance situations. So this is a specific diagnosis code, just like the last one was tracheostomy. And when I look at the diagnosis code, and by the way, these bars are sorted by how many of those diagnoses happened in that insurer. But as you can see, this one insurer has 10 days excess length of stay. And for this diagnosis, everybody has excess length of stay. So clearly this is a diagnosis where they're not doing so well in general. But for one insurer to have that significantly higher excess length of stay, that allowed the hospital organization to rally around figuring out what's going on there, right? So this length of stay patterns can be both useful from a treatment of patient perspective as well as what's going on with billing and coding perspective as well. Those were my primary slides, Julie, so if you have any questions for me.
Excellent, thank you. Yes, we do have several questions. So one of our audience members is wondering, what tools and language do you use to implement the statistics code?
We actually wrote our own statistics code using Java, so we actually are using some openly available Java class libraries, but essentially we wrote our own code because what we are doing, almost think of it like a search through all of the drivers of the outcome, right? It's a search-oriented approach to statistics as opposed to a traditional statistics-oriented approach to statistics, where you go systematically through every variable combination and calculate the statistics. That would just take too long if you have to calculate this much stuff. So because we had to come up with our own proprietary approach, it was just easy to write it in Java. But the approach I'm talking about, the broader advanced analytics for all, you could replicate this in any system that you want to do as long as you focus on how to focus on the examples rather than the statistics and how to make the analysis simple. You could do this in anything you want. The principle is more important than the specific implementation that BeyondCore Lucid built.
Mm-hmm. And you mentioned the issue of quality and maintainability of analytical code. But I, as well as one of our audience members, is wondering, sort of, when you have that wrapped under a visual solution, how can the analyst be sure that the software is giving the right results? In other words, don't you still need, 1 or 2 PhDs, or don't you still need specialists to make sure that the computer is doing its job?
Right. We call that showing our work. So it's actually kind of funny. We first came up with the executive dashboard that we expect people to use all the time, right? There you see 6 examples and in sort of tiles, visual tiles like the examples I was showing you, and you flip the tile and it shows you more detail for each example. But then we found that, hey, that was not detailed enough for the business analysts because they were like, I don't quite believe you. So we gave the business analyst the ability to go in and see exactly what variables were considered, how important of a predictive driver it was, etc. And you could drop down and see each example for each variable combination. And then we found the statisticians came in and said, well, what was R-square? What was RMS, right? I want to see a cluster graph. I want to see a topology graph. So we actually do put that in. So a statistician can go in and see a topology graph, can see a cluster graph, can see the regression, can see the root mean square. And that allows us, and we basically say that's just for winning debates with statisticians, right? So that the statistician can feel warm and fuzzy about these guys did some real work to come up with those 35 examples. But the power of the technology comes from being able to automatically figure out those 35 examples that are important rather than all the math we are doing to end up there.
Mm-hmm. So speaking of that number 35, that came up in the K-anonymity figure too, where it never gets more specific than 35 people. Why is that the magic number? How does it arrive there?
That was just this 35 was just an accident.
Sure. Yeah. Well, but the question still stands, and I'm sorry, but in addition, one of the audience members wonders if K-anonymity is not a hurdle against better results, and how do you balance that?
That's actually a very good point. So if you set the K-anonymity number very high, it would be a hurdle, right? Let's say I set the K-anonymity to 500. Then I might be losing some very important clusters. You can set K-anonymity as low as 10 if you want. I wouldn't recommend going lower than that because at the point of 10, you can probably start figuring out, you're down to 10 people, you might do some follow-on the ground research trying to figure that out, right? But the reason I like 35 is just as a statistician, I tend to not like clusters below 30 or 35 anyway. So I just said, okay, fine, you know what, I'm going to set the default to K-anonymity of 35 and let the users change it. Okay. On the other side, the examples we find, it might be 10 examples, it might be 100 examples. It just depends on what examples get above a certain threshold. And the user can always go in and say, show me more examples. So then instead of 35, they would have seen 70, or they would have seen 200, depending on how low we put the threshold above which an example becomes interesting.
Mm-hmm. Well, thank you so much, Arijit. And